Hi, this is Sandeep from India and I work for Rights Limited. This video is first video of vlog series. The idea of vlog series is that young member nations will develop their videos and share it, and ITFIM will support it and share it across the nations. This series will help in creating a platform where young tunnelers can come forward and share their experiences so that we can learn from what is going around in other countries. Today, I bring you a project where we designed 4 tunnels between Baiguda and Laxmipur section. So the presentation will be focused on how to design a tunnel, uh, focusing on the aspects that it is located in a non-urban scenario. We will go through the desk study, the field study that we did, the design that we did, then considering the environmental and social impacts associated with the project, followed by the risks involved with this location, and the value addition that we propose to the client. This section is located in state of Odisha, which is on the southern east side of India, and it is a densely forested land, hills which are of medium height, not as high as Himalayas. The rock here is of volcanic origin, and mostly it is granitic gneiss. This is an interesting project because when it was proposed, this was to be a link between India and Japan to take the resources from India to Japan and bringing back the manufactured products. First, one of the lines was opened in 1968, and now as the production has increased, to enhance the capacity of this railway link, the second line is being proposed parallel to it. Although the link was never able to reach Japan, but it is now serving the industries in this region. So we are planning 4 tunnels in this section, which are approximately 3 kilometers long. So the project started with a visit to the site, and the team visited, and we walked through the existing track and existing tunnels, observed the geology. We went inside the 4 tunnels to see what's the condition of the lining inside, and we found that there were places where there was no lining at all because the rock was so competent. There was no water ingress, which was adding to the stability of this region. The alignment was studied, and the desk study was also done, where the freely available satellite data was collected from internet, and the alignment was drawn with few alignment considerations for a maximum speed of 100 kilometers per hour of the train. Ruling gradient was 1:1:100 and a maximum curve of 5 degrees to make that possible. Now this data was collected in the office and was studied. We identified the locations where there was appropriate cover and identified the location for the portals for the tunnel, and the length of tunnel was studied. Considering that this is a desk study and the accuracy of this data is as good as the data available from the satellite, so we sometimes have inaccuracies of 5 meters in measuring the distances. To make this study even more accurate, we went on the field to do the detailed survey of the region by leveling, traversing DGPS, and using the drone-based surveys. And after doing this study, we could achieve the accuracy of 1 millimeter to know the exact topography of this region. We will have a look at one of the videos that we took using drones while we were doing the survey. So we can appreciate that there is existing tunnel, and there will be another tunnel on the left side of this tunnel. Then there is a road. So this is how the dense forest is in this location, and this is totally in a remote area where there is a lack of accessibility. So moving on to the field studies, like we have already seen, that data was collected from all the surveys, and the topographic data that we had now had accuracy of 1 millimeters. And then the location for the tunnel portals and the length of the tunnel was again worked out. Uh, so you can see one of the examples of the plan and developed for the tunnels and the contours that were developed. So after this, the other information that we required for designing a tunnel was geotechnical site investigations and testing. So as per the desk study, we proposed few boreholes that we needed to do. And at some locations, it was easy to transport the machines using cranes. But at some locations, they were so remote that there was the road was even not close to the tunnel. So we had to drag it through to the top of the hill with the help of laborers in the vicinity. After taking these courses, we did other form of investigations as well. We went into the tunnels, observed the type of rock, type of joints inside the existing tunnels. We went on the top of the hill and observed what type of rock and joints are present. Then we did seismic refraction surveys, geophysical surveys based on seismic refraction technology. Then we bought these samples back to the testing laboratories, tested them, got the engineering properties out of them. By the time these field studies were happening, we were one of our teams was already working on the cross section of the tunnel. So to decide an appropriate area to be excavated and the tunnel cross section, we had to consider all the electrical, mechanical, ventilation, and safety aspects. And of course, the train has to go through it as well. So once the cross section of the tunnel was developed, now and with the geotechnical as well as the topographic survey data we had with ourselves, we moved to the design. The design included a rock mass analysis using FEM software, and then kinematic analysis using various softwares. We saw what type of wedges can form into the tunnel and what type of support do we require. After the design, then we were to consider the social and environmental impact of constructing this project. So we observed that total number of trees that were proposed to be cut were 872, and as per the legal setup in India, we have to plant 10 trees if we cut one. So we plan to plant 8,720 trees once the project will be constructed. There were no species which were in endangered list of IUCN, but we found a few endemic species like barking deer and sloth deer in this region. And it was proposed that a detailed survey of this has to be carried out by the contractor during construction stage, and a rehabilitation plan has to be proposed. We also observed that other than flora and fauna, there are few tribal people living in this region, and the main source of income for them is agriculture. There were some agriculture lands which has to be relocated, so they have to be supported either by giving similar kind of land or by supporting with compensation as per the law. Moving on to the risks identification and the mitigation measures of this project. Since we are not in urban environment, we don't have to worry about the surface settlements. Although we have other risks that are associated with this region, like air pollution. So all the pollution that will be generated through the construction activities and the movement of the machinery and vehicles has to be mitigated. Yeah, so the strategy to mitigate is through regular monitoring, to use water sprinklers, to use energy efficient machines, and to switch to electric based machine rather than the fuel based or diesel based machine. Next is noise pollution. Although there is not much of a habitation around this place, but controlling noise is important from the point of view of environment and the limited population that we have there. So we in the sensitive areas we have to limit our noisy, loud activities to the daytime, and in the regions where we do not have this problem, we could go and work day and night to complete the project. Groundwater contamination, since this is a green landscape, we have a responsibility to protect it and not contaminate it. So choosing right chemicals, choosing right grouting materials is very important while we design this tunnel. More than 1 lakh cubic meters of muck is estimated from this project, and disposing this huge quantity of muck is a challenge. It is proposed that the contractor, when engaged, should prepare a plan to dispose this muck and have a minimum impact on the surrounding regions and this landscape. Value addition is a very important aspect of every project, and we have proposed two value addition measures considering the situation of this landscape to the client, and it's up to the client to adopt them. First is extended portals. So what we have proposed is we should extend the portals of the tunnel so that the muck that is excavated can be backfilled over the tunnel portals, and so that it doesn't need to be transported, which will save both cost and time, and will help in regenerating the beautiful landscape in this region. Second is, since the rock is very competent, and we have seen that at places we do not even need permanent lining, we have proposed that we could do a composite lining, that when we do the primary lining, we can utilize it as a secondary and as a permanent structure later on. So with this, I conclude my presentation, and if you have any queries, please do not hesitate to reach me on my Gmail address. And if you are interested in creating a video blog and sharing it with ITAYM, please do share it on ITAYM email so that the same can be circulated. Thank you very much.